Today we're going to start our next unit on polynomials. Now, you definitely have talked about polynomials. In fact, even in the last chapter, we were working with polynomials, but we're going to dig deeper in this unit. We're going to learn other things, new things about polynomials. And perhaps maybe the first thing we should do is make sure that we understand that not everything is a polynomial. Sometimes students think polynomial is just kind of a word that means equation, but it's actually not true. Polynomials have to have a certain look. Did you know that a polynomial, it's not going to have a fraction in it? You'll never see a fraction in a polynomial. Well, a polynomial is never going to have like a square root of sorts. You'll never see a square root in a polynomial. There's actually other functions you wouldn't see either. That's because polynomials, like I said, they have to have a certain look. The look is that, well, that they will have terms, that these terms will have perhaps powers and exponents. And when we have something like that, well, then we have a polynomial, like this one. And what I want to do is even name it p of x, which is just a way to say that this is a polynomial. X cubed plus 2x squared minus 16x minus 32. Now, this is just a little intro for the whole unit. In a moment, we will get to today's worksheet. So just kind of watch because, well, because does this look familiar from the last chapter? Yeah, there's things that you've done with polynomials already, like you factored them, perhaps using like a grouping method, where you would take out a greatest common factor and hope that when you did this correctly, that you would be left with the same thing. You would be left with, in this case, x plus 2. So it looks like that we can factor polynomials. Again, like in this problem, with a grouping method. And when you continue to factor this, that is the x squared minus 16, you realize that that can further break down as a difference of squares into x plus 4 and x minus 4. So what happens when you factor a polynomial? Well, maybe I should say, why are we trying to factor this? Well, because we like to think about it equaling 0, and when it does equal 0, we're able to easily solve. We're able to easily solve each of these groups for the zeros. And we're going to learn in this unit that when we have those solutions, that we can graph it, that we can actually graph it with much ease because, well, because these numbers that we found, they are actually the x-intercepts of the graph. And further, when we think about this p of x that we started with, that is the x cubed term that we see in the front, that we actually know that this graph is going to, because the leading term has a positive coefficient, we know this graph is going to be going up to the right. We also know that the graph is going to cross through these x-intercepts, and then it's going to have to be an opposite direction to the left. Now, the reason it's opposite is because the degree of this polynomial is odd. Now, if I did too many things there as a little intro, well, good. I wanted to do a lot of things. I wanted to show you guys that we're going to be able to understand all kinds of things about a polynomial just by knowing what's true about the original function. And we'll be able to discuss this end behavior, that is what the graph is doing at the ends. We'll be able to discuss these zeros, or these roots that we found. Remember, zeros and roots are the same thing. We will actually also know why the graph is turning twice, that it has two turns. And there'll even be some other things that we will learn about a polynomial, all of which is, of course, what is in front of us in this unit. But what we need to do is we need to start sort of back at the beginning. We need to start with some basics about polynomials. And this is where you can grab your sheet and begin with me by classifying a polynomial. Yeah, we can classify a polynomial. Now, This polynomial that we're starting with here, it's actually kind of out of order. And when it's out of order, we like to put it in what's called standard form. Standard form would be when the exponents go in descending order, and descending just means that we're going from the highest exponent to the lowest exponent. That's better. Now it's in standard form. And when I have the equation in standard form, I'm able to very easily see what's called the leading coefficient. The leading coefficient is what it says. It's the first coefficient, or better, it's the coefficient that's with the highest exponent. Specifically, we see that this leading coefficient is positive, which is going to be something that is special. Now, we also see what's called the degree of the polynomial, and the degree is just the highest exponent. And finally, and because this is degree 4, we have sort of a special name for that. We call it a quartic. That's just a word that we use to describe the highest exponent, that is the degree being 4. Now finally, there's 3 terms here, and when we see 3 terms, we would say that this polynomial is a trinomial, a word that you've heard before, but trinomial just means that it's got 3 terms. And what we like to do is we like to take that quartic classification and sort of put that in front of this so that we say that we have what's known as a quartic trinomial. A quartic trinomial. It just has a degree 4 and 3 terms. Let's classify another polynomial. This polynomial doesn't seem quite as big, but it's still out of order. Remember, when we write things in order, we want them to have the highest exponent first, down to the smallest exponent. In this case, the highest exponent is just 1. And remember that the highest exponent is called the degree. Now, when the degree is 1, we say that this is a linear polynomial. Another word that you've heard before. Of course, linear just meaning straight line. Remember that leading coefficient? Yeah, the leading coefficient, sometimes just abbreviated LC, is going to be -5. Emphasis on the fact that it's negative. And finally, there's only 2 terms here. What do we call a polynomial that has 2 terms? That's right, we call it a binomial. Another word that you've heard before. And we like to take the word linear and stick that in front of this, and thereby say that we have what's known as a linear binomial. A linear binomial. It just means it has 2 terms, and the highest exponent is 1. Why don't you try to do a little bit of organizing and classifying for these 2 practice problems? Go ahead. You should be able to put this in order. You just want to have the highest exponent first, down to the smallest exponent. The leading coefficient is just the number in front of that highest exponent. Now here we would say that it's negative, it's technically -1. The degree is 3. You know there's a special name for degree 3. That's right, it's called a cubic. A cubic. And since there's 2 terms here, we can call this a cubic binomial. Remember, binomial just means that there's 2 terms. How about number 2 here? Does it seem like it's out of order? You just want the exponents to go from highest to lowest. The highest exponent here is 2. Remember, 2 would be the degree of this problem. We have a special name when the exponent is 2. Remember that from last unit? That's right, it's called a quadratic. Quadratic actually means degree 2. How many terms do we see here? 3 terms. So it's a trinomial. Specifically, a quadratic trinomial. And don't forget about the leading coefficient. It would be +3. Well, we will continue to talk about polynomials in terms of their classifications. But what I want to do for a second part of just kind of some basic intro ideas is just talk a little bit about simplifying polynomials. Like maybe adding or subtracting. In the case of this problem, we're clearly subtracting. And what you want to remember is that when you're subtracting, that subtraction sign is going to distribute, it's going to apply to each term in that parenthesis. What I'm going to do here is I'm going to kind of rewrite the problem with the opposite, or with a negative in front of each term. Now we can kind of feel like that we're just adding like terms. Now 5x cubed, that doesn't have any other terms that are like it because there's no other x cubed anywhere, so that one will just stay the same. But the 6x squared is like the negative 15x squared because the exponents are the same, so we call those like terms. And of course, if you add them together, you get negative 9x squared. How about this negative 3x right here? There's nothing else that's like it, so we'll just record that next. And then, of course, the plus 2 is like the plus 12. They're just called constants. And we can add those together and just get 14. So we have simplified that polynomial. We basically subtracted, or maybe you might say we turned it into an addition problem once we distributed the subtraction. This looks like fun. Looks like we're going to take this x squared y and we're going to distribute it into this entire trinomial. Now when you do that, you're multiplying. And when you're multiplying, you're really just going to increase the exponents. So now the x squared, nothing multiplied. There was no other x's that multiplied to that. But when you multiply these y's, you now have y to the fourth. Notice that what I did there was I actually added those exponents to change that to y to the fourth. How about this one? When I distribute to this negative 28x, now I'm going to have more x's. I'm going to have x to the first, x squared, a total of x to the third. The y right here, nothing changed it, but it's still part of my answer. And then we distribute to the 30. All that's going to mean, though, is that we're going to end up with 30 in front of x squared y. What about this plus 20 x cubed y? Well, I didn't distribute to that, but it's still part of this problem. It's still here, so I'm going to bring it down so that I can, well, that I can add like terms, because here I have negative 28x cubed y's, and here I have 20x cubed y's. How many x cubed y's do I have now? That's right, negative 8x cubed y's. Now notice that I didn't change anything with the exponents or the variables, but I did add the coefficients together. Now is this answer in standard form? It's kind of hard to tell because I have multiple variables. But what we do in a case like this is that we say the total number of exponents would be like my exponents. So here I have a total of 6. Here I have a total of 3. And here I have a total of 4. What we're trying to say is that we want the 4, we want the 6 to come first, then the 4, then the 3. Okay, now I'm just talking about organizing the answer. I'm not talking about actually adding any of these exponents together because they are all different. But I am going to put my negative 8x cubed y and then my 30x squared y at the end. And technically now it's in standard form. What about multiplying, or a more advanced type of multiplying? Well, it's just going to be the distributive property. Just going to have to do it again, and maybe again if necessary. So just remember that this x is actually going to multiply, that is distribute, to each of these three terms. Now notice that I'm increasing the exponent as appropriate for each of those. But then this negative 4, it's going to distribute, that is multiply, And when I multiply negative 4 times negative 8x, I get positive 32x, as well as some other terms here. Once you're done doing that distributing, then it's time to add like terms again. There are no x cubes, but there are some 8x squareds. There actually happens to be two negative 8x squareds, which now give me negative 16x squared. How about this 10x and 32x? Yeah, that's going to be 42x. Just add those together. And then I still have this minus 40 at the end. And so we did a little bit of distributive property again and again and again. Well, actually, you're going to need to do that distributive property numerous times for this one, because remember, you can't just bring this exponent in. You can't just cube everything. That's a math teacher's nightmare. I wake up at night yelling, no, no. Instead, we say that if you're going to cube something, well, that means that you need 3 of them. You need 3 of them all lined up to multiply together. Now, this looks like a lot of fun, and it will be, but what I need to do is I need to basically do 2 of them at a time. I don't want to somehow try to do all 3 at the same time. So here we go. We're going to do the distributive property. X times x is x squared. X times negative 2y is negative 2xy. Negative 2y times x is going to be another negative 2xy. And then negative 2y and negative 2y is positive 4y squared. Now, I still can add these like terms together, so I'm going to do that. I want to completely simplify this, which means I now have negative 4xy's, as well as the x squared in the front and the 4y squared at the back. Remember this x minus 2y right here? Well, it's time to distribute that. I actually want to distribute again. Now, you can distribute from left to right. That's fine. I like to always take the smaller, binomial right here and distribute that into the larger binomial. So I'm going to actually show it to you that way so you can see how we can sort of distribute backwards. That just means I'm multiplying everything by x, which means I have more x. Notice I have x squared right here. So that's what you get when you multiply x into that trinomial. But what happens when I multiply negative 2y into the trinomial? Well, it's just going to be negative 2y times x squared. It's going to be negative 2y times negative 4xy. Now that's 2 negatives make a positive 8. We also have some more y, so now we have y squared. And then negative 2y into the 4y squared is going to be negative 8y cubed. Are you keeping track of everything? Because there are some like terms. There are some like terms. Let's see here. This x cubed, nothing's like that, so we'll just keep that. But how about this 4x squared y? Isn't that the same as this negative 2x squared y? In other words, they have the same kind of variables. Yes, so I can actually combine those together to be negative 6x squared y. That was kind of cool. How about this 4xy squared? That's kind of the same as this 8xy squared. So it's going to be 12xy squareds. Notice I'm not changing the exponents. I'm just adding the coefficients. And then this negative 8y cubed, well, that's just going to come down to be part of my final answer, which is in standard form. Looks like there's a couple problems for you to practice. Do you want to, well, you should want to see if you can distribute here and simplify. Uh-oh, that's the same problem that we had up above. Okay, I'll have to get that changed. Actually, it will be changed on the paper that you have. Let's just change it here right now so that it looks like the one on your paper. How about x plus 3 and then 3x squared minus x plus 1. That's the one you should be practicing. So you're going to do the distributive property. Make sure you increase the x. Notice that when you take x times negative x, that you get negative x squared. And then when you take x times the 1 at the end, you just get x. We're going to distribute 3. That means you're going to multiply everything by 3. 9x squared, negative 3x, and plus 3. It's time to add your like terms. There's nothing like 3x cubed. That's because there's no other exponents like it. But there is something like this x squared. There's a negative x squared and then a 9x squared. That should give you 8x squareds. There's also an x and a negative 3x. That'll give you negative 2x. Just add the 1x with the negative 3x. And then this plus 3 at the end. Nothing is like that, so we'll just bring that down. Here we have a problem that sort of combines both the distributive property with some additional addition and subtraction. Now make sure you distribute negative xy. Negative xy times y is negative xy squared. But it's going to be positive 4x to the third times y. Now this xy squared out front here, yes, it has parentheses around it, but the truth is there's no more multiplying anywhere in this problem. We can sort of take away those parentheses because we want to be able to freely add the like terms together. Those like terms look like that they're going to cancel or add to be 0. So all I have left is this 4x cubed y, which I'm going to actually write first, remember, because the total amount of exponents would be 4. So we want to have that first in our list. And then this 3x, I'll just kind of write that second at the end there. So we first distributed, and then we did a little addition and subtraction of like terms. Now we have many other things to learn about polynomials. You might notice that there's one operation we didn't do. We did addition, subtraction, and multiplication. But what about division? Well, that's what we're going to be doing next. Polynomial division is kind of a whole different monster. But for today, we have a lot of review, of course, of the basic ideas. And I would definitely want you to practice those in this set of homework problems. It kind of looks like a lot, but you're just going through some of these basic ideas. And tomorrow, like I said, we will pick up with what's known as polynomial division.